Hello there, my name is Tallard, and I'm participating in Challenge 2014. Today I'll be showing you how to solve a Math 1000 problem from the T-Square website. I'll be doing question number 8, which involves basic related rates problem with simple differentiation. So let's get this started. The question starts out by describing to us the formula of a sphere, which is 4/3 pi r cubed. This given formula is just here to remind us what it is and giving us a hint as to what's going to be expecting from the problem as we continue reading forth. So the question describes to us a balloon being filled up with gas at a rate of 25 cubic inches per second. And then the main problem is being given to us here. So the question is asking us how fast is the radius of the balloon changing once the radius is at 18 inches. So what I like to do for related rates problems like these, I pretty much write down a description of each part of the problem in the form of calculus and variables in order for me to figure out what I need to solve for and see if I can find the solution from the variables I write down. So let's see what we have here from the description. So the balloon is being filled up with gas at a rate of 25 cubic inches per second. What this means is that the balloon is expanding and increasing its volume at this particular rate. So the way I write this down in variable form is the derivative of the volume with respect to time being equal to 25 cubic inches per second. Then the main problem is asking us how fast the radius is changing with the balloon. So the derivative of the radius with respect to time is what we're looking for, at radius being 18 inches. So what we're solving for here is dr over dt, and we have d over dt and r. Now from what formula can we solve for this is what we were given in the first place, which is the formula for volume of a sphere. So write down the volume for a sphere, which is 4/3 pi r cubed, and here we have the formula. But here we can't we can plug in r, but we can't plug in dv or dt. So what we need here is to derive the formula to solve and see if we can find our final answer for d over dt. So deriving this formula with respect to time will give us 4/3 times pi times the derivative of r cubed, which is 3r squared times dr over dt. Now the reason why I multiplied this by d over dt is because the formula here has a variable of r and not t, and we need to derive this with respect to t or time. So when we derive our r cubed, we're deriving it with respect to r and not time. So in order for me to show this formula being derived with respect to time, I'm going to multiply this with dr over dt. So here, let me just rewrite this and simplify this a little bit more to make it easy to view. So dv over dt is 4 pi r squared times dr over dt. The way I got this 4 pi r squared is from previous line I shown here, where using if you use basic math here, the derivative r cubed will give us 3r squared, and this 3 is number 3 right here is being multiplied with the 1/3 from the 4/3. So 3 times 1/3 will just give us 1, and this will leave us with 4 pi r squared. So that's how we got over here. Now as you can see, we have the right form for the formula, dv over dt, and we can now plug in our elements that we know of. So dv over dt is 25 is equal to 4 pi times r, which is 18, squared times d over dt. And this is what we're solving for. So we'll divide both sides by 4 pi times 18 squared, and this would allow us to solve for the variable dr over dt. So dr over dt is equal to 25 over 4 pi 18 squared. Simplifying this even more will give us 25 over 4 times 324 times pi. Simplifying this even more, and final form will give us 25 over 1296 pi. And this is our final answer. So dr over dt is 25 over 1296 pi inches per second. Now if you want to plug this number into your calculator, you could get the more basic and accurate form of this, so we can get an accurate answer for this question. So if you plug it into your calculator, you should get something like 0.00614 as your final answer. And there you go. This is how fast the balloon is changing at 18 inches. So I want to thank you for watching this video, and I hope you have an amazing day.